Hey everyone, thanks for checking out this webinar. I'm Hari Narayanan. I'm a staff data scientist who spent a lot of time working with analytic problems in subprime lending. I get to work with data scientists, analysts, executives in the space. I'm happy to share this knowledge with you all. We are going to learn the domain, understand the problem, and see how modern analytics tool can solve challenges that traditional analytics cannot handle. By the end of this, you'll understand not just what subprime lending is, but how to think about the analytic problems in this space and how a lot of these problems apply to many of the high stake data science challenges you could face. We'll start with subprime lending fundamentals and some of its core functional areas such as origination, servicing, and collection. Establish where analytics could add most value. Then we'll address common risk problems in this industry, such as first payment default, early delinquency, fraudulent transactions, and so on. And we get to discuss some of the data sources typically available to tackle these challenges. The core of our discussion would be focused on why traditional BI falls short, how statistical AI and feature engineering can uncover multi-factor patterns. We'll walk through dotData capabilities specifically around automated feature engineering, threshold discovery, and driver stacking. Finally, we'll look at real use cases with actual impact from this field. Many of you might be familiar with lending, but what's different with subprime lending? You are extending to borrowers with FICO score under 640. You're lending to someone who's not having enough credit history or someone with past delinquencies, irregular income, people who are hourly workers, gig workers, contractor. And in this scenario, many folks might not have enough credit history or have a limited credit history. Those folks who do not fit into the traditional lending patterns, they all fall into this subprime lending space. The modeling approaches for subprime lending varies a lot from the traditional approaches because here either people have a bad credit history or a new credit history. And that what makes this industry more challenging. The things we need to understand are what they are borrowing the money for. For example, they might be borrowing it for essential needs, such as vehicle to get to their work, paying medical bills, emergencies, and housing deposit. Whenever someone borrows to keep their car running so that they can get the job, the loan becomes a priority payment. Here's what matters for data scientists or analysts working in this space. Your margins are razor thin. Net charge off might be 8 to 10%, operating costs are high, and you're often looking into single digit profit margins. So 1% in accuracy improvement or early delinquency detection, that's not just incremental, that's material for your business. And it could help you save millions in savings. Here are the three challenges we see over and over with subprime lenders. First, over reliance on FICO. FICO score is a useful, but it's backward looking snapshot based on credit bureau data that might be 30 days, 60 days, or 90-day old. Meanwhile, you have probably got bank transaction data showing what's happening right now. Someone might have a 580 credit score from past issues, but shows 12 months of steady deposits and zero charge of fees currently. Or they may have a 620 FICO score, but the bank account shows a recent problem. When you use a traditional model for these kind of problem, you would run into this problem of developing a shallow model where FICO is the only one which is being considered, but all these recent signals are not being addressed. So this poses a problem where you're not handling dynamic risk. The second problem is application data relies in one system, bureau data relies in credit agencies, bank verification exists in some other data set, and servicing could existing in different platforms. Since all of these are getting stored in disparate sources, sometimes people might not discover everything to make sure like they are doing the right thing. So your data team spend a lot of time on integration before they even start analyzing. Third, descriptive versus predictive. Traditional BI tells you first payment default went up 2% last month. Okay, but why? When you have to find the reason behind this, you might need to spend a lot of time branching through different data sources trying to find the root cause. Maybe it's geography. Maybe you could check the FICO bands. You might also want to check the bank statement and so on. But there are thousands of this kind of combinations. Some patterns just don't get discovered because nobody thought to look at the specific combination of factors. These are limited, but they create real constraints on what you can do analytically. Let me show you where these challenges hit hardest. In order to understand some of the challenges, let's take a step back to understand some of the key foundational area for this space. As you can see, the three functional areas primarily being addressed in subprime lending is origination. Origination where like an individual would go and apply for a loan. And during this time, there are several models being developed to make sure we are providing loans to the right individual. A mistake in origination when you're developing a model is highly expensive because they could compound over the loan's life. Approving a wrong decision, you're dealing with loss for years, not just for months. Declining the right person, you're also losing the revenue. So it's an extremely thin line where a model in origination has to do well in identifying the right individual versus the wrong individual. When it comes to servicing, this is after the origination happens. So when an individual is provided with a loan, they will become part of the servicing. Here, the loans are managed after funding. This is critical in subprime lending because situations change. Let's say you provided to an individual who has high chances to repay the loan, but things could change as they got the loan. Their house could get cut. They might have unexpected expenses hit. Their income could drop and life might happen. Can you spot early warning signs before someone misses a payment? It's becoming critical because here they're currently having a loan and depending on how much tenure they have spent with the loan, the amount they would have recovered from this individual might be enough or not enough. This question of whether someone is going to miss payment is more proactive than a reactive approach of reaching out to someone who missed a payment. Because interviewing when they are current has way better outcomes than waiting until they are 60 days past due. In collections, it's the stage where the servicing could have failed. You weren't able to make the individual pay for whatever dues they have. Collection is where you're trying to get recovery from this account as much as possible. Not every delinquent account should get the same treatment. Someone has good recovery potential and deserve more effort. Others might have low potential and you don't want to overinvest. The challenge, how do you know which is early in the process? Each area is opportunity for improvement for better analysis. Let me show you how loans follow through these stages. As you can see in the flow chart, the first blue box indicates the origination. Here a borrower would apply and the decision is made whether to provide loan to the borrower or not. Let's say ultimate decision is to provide loan for this individual. So you pass through the approval stage and during the servicing you monitor for payment just to make sure the individual is paying on time. And if there is a small delay in payment, you decide when to make a touch point so that it doesn't go to a larger stage where what we call as a delinquency. In the sense like the individual don't pay loan for 30 days or 60 days and so on. During servicing, if the payment is happening on time, there is a point where the loan gets mature and this is like a really good stage. The problem happens when you monitor for payment, but the person was not able to pay on time and there is a continuous delinquency that happens. That's when the recovery would play a role. This goes to collections, as you can see in the pink box. And during the stage of collection, you would monitor for events like charge off or a reprocessment, or sometimes you will need to close account. And we will go through the details on what happens inside collections, origination, and servicing. Origination has four main risk problems. First, payment default. So for instance, let's say someone is provided with a loan, but they haven't even made the first payment. So this is particularly painful because they haven't even covered any cost yet. Typically, first payment default might be 2 to 8% in the space, but some segment might have 15% while others have 1%. Understanding what drives variation is extremely valuable here. Early delinquency. So let's say an individual is provided with a loan and within 60 days without paying for the loan in the first 6 months, it's considered an early delinquency. Even if they don't fully default, these accounts need immediate attention and have elevated charge off risk. Charge off in the sense like if they keep doing this, they have chances where they don't get to pay the whole amount of the loan and eventually the loan could be forgone. So there is an immediate need to act during the stage of early delinquency. Fraudulent applications during the time of originations, it's critical to identify if the individual has falsified income, employment, or ID. Fraudulent patterns evolve, so you need analytics that can detect new patterns, not just catch old patterns. And the riskier part is a thin file applicants. These individuals have insufficient credit history. So this is where actually trying to understand where there is a more opportunity for someone to pay off is critical. Traditional models struggle a lot for these. Thin file doesn't mean high risk. You need to look at alternative signals like bank patterns, trend payments, employment stability. Many lenders decline thin files because they can't score them, but there are good borrowers in that application. When you're leaving a good borrower, you're also leaving your revenue. Now, let me show you what data you could have available for these cases. From a data perspective, origination has three stages. Application stage, you're gathering data from multiple sources. This could be like all the credit bureaus like Experian, Equifax, and so on. During the stage, you have information like loan amount, employment, stated income, and it could also contain the information from the different bureaus like Equifax, Experian, and so on. So it could contain information like what's the overall credit score, number of trades they have made, what's the number of times they had delinquency, their employment verification, and so on. All of these are valuable, but these are coming from different places. When you're developing a model for predicting the default probability, you need to identify the approval threshold, or you could also have a model to determine what's the appropriate price for pricing this individual. Each requires combining data from multiple sources and finding patterns. If you would see a person with a good credit history might have a lower interest rate, whereas a person with a recent credit history. All of this is because of whatever signals is being derived from this individual, in addition to other external economic factors. And finally, when you have this in the origination stages where you have a decision model that would decide whether this individual is going to be approved or declined for a loan. Here is the opportunity. Most lenders use a fraction of available data, or they analyze each source separately rather than looking into the combination. And when you are doing it on a separate data source or just looking into one source, you're also leaving money on the table. That's where the hidden patterns are in this intersection between the different data sources. Let me show you an example. Here is a key difference between traditional BI and dotData. You could be asking, show me the first payment default rate by FICO score band. You would get a chart that could have all these FICO bands, like between 500 to 550. The overall chances of delinquency is 12%. Between 600 to 650, you might have another data that says the overall delinquency is 6% and so on. All of these are useful, but not actionable. Because let's say someone just graduated from the university. They might have a low credit score, but could also have a high paying job and a good bank balance in the last 1 year. So just looking into FICO score might not be enough. What dotData does is it tries to identify multiple factors, not just restraining to few sources. So for example, it could find interesting pattern like this is an hourly worker working on a gig employment and they applied loan on a Friday or Saturday with the overall debt to income ratio of 42%. That means this person might not have a stable income and their overall debt ratio is more than 40%. And sometimes when they're applying on a Friday or Saturday, it could mean they need money to either get a car from Monday or pay housing loans and so on. So when a person applies for loan, dotData would not just give you the credit score, but also give you all this hidden signal that could be useful to decide whether to provide loan or not. So it's not just one variable, but a combination. dotData, it's not like just giving you the yields, but it also identifies magic threshold. So what it says is when this combination happens over 42.5%, the overall ratio of default becomes 3 times more. So all this kind of signals, the threshold identifies it extremely useful because it's not just identified on few records, but on the thousands of split data points on multiple sources. And the good part is it's actionable because when you have the information of the user, you also have the signals relating to the user. That way you can decide whether to provide loan or decline this loan, price them higher, or even flag for review. Could a smart analyst find this manually? Maybe if they thought to test the exact combination of the exact threshold. But it's not just one combination. We are talking about more than 4 to 6 data sets with a longer history of the time period. And all of this is not easy to process, but the great part of dotData is it can handle all of them within hours. That's the fundamental difference between comprehensive pattern discovery versus doing it manually. What we observe so far is traditional servicing is reactive. You will wait for missed payment and someone would call and ask them to pay for it. So it's always being reactive. Wait for an event to happen and then react based on the event. Deep analytics enables proactive servicing. So you don't wait, rather you watch for signals. And when the signals are telling you there is a hidden problem, you'll reach out. Individually, there are small signals. Combined, they might need elevated risk. Here is why this matter. Intervene when someone is current, 70 to 80% success rate, keeping them current. Wait until 30-day past due, the chances of getting the money back drops to 50 to 60%. Wait until 90 days, you are a 10 to 15% cure rate. So that's why on these kind of problems, it's kind of predominant to have early intervention. When you let it pass through longer stages, the chances of you recovering the loan goes down a lot. But essentially, when you understand, you cannot call everyone every month. You need analytic to identify which accounts are actually at risk. And that's where dotData deep driver stacking helps a lot. Let's say you're predicting delinquency. Accounts with zero risk drivers might have like a 5% delinquency rate. One driver could signify a 7% delinquency rate. And when you stack more than three drivers, it could attribute to 32%. What do I mean by stacking the drivers? So if you have got like 50,000 active loans and 8% have three risk factors, that's 4,000 account. Focus your proactive reach on those 4,000. The other 46,000 gets automated monitoring. So that way you are not reaching out to all the individuals, but rather channeling it out to just 4,000 individuals. That's how you scale personalized servicing without scaling headcount proportionately. And it's explainable. You can tell your team exactly why an account got flagged because the signals will tell you why. For example, the signal could be partial payment in the last 2 months, no portal login in 30 days, not in a good spot to pay off the loan, and lives in a high unemployment area. This could give like a lot of deeper problem that's happening to the particular loan. And the advantage here is it's not black box. You would get a clear signal on why dotData identified certain accounts for risk. Now let's talk about what happens when accounts become seriously delinquent. Delinquent account typically progress through stages. It could be 30-day past due. It could be 60-day past due, 90-day past due. So 30-day past due is where you have chances to do early intervention. So someone could make a call and ask what's going on. This has decent chances of paying off the loan and proceeding to a healthier state. 60 days where the individual with the loan might have hardship programs. In those scenarios, better to intervene and decide whether to give them a repayment plan or see if the risk model needs to be attributed again. 90 days where this account is non-performing, manual collection for a lot, and the chances of recovering it becomes low. And charge-off is where like you decided you not able to recover money from this individual. So asset reclaim or write-off of the loan is needed in this stage. So if you see here, 30 days, 60 day, 90 day, all of them looks like a delinquency problem, right? But when you deal with each of them, the risk associated to a 30-day versus 60-day versus 90-day and charge off are different. So you cannot use the same model, and sometimes the same data set might not be the one that needs to be analyzed. So that's where you would need to use a tool like dotData, where it could watch for signals related to each of this separately rather than looking all of them into one. Collections can be like one size fits all. Different accounts need different sizes. Let me show you what it looks like for delinquency and collection stages. You can schedule delinquency and collection into 4 categories. One is high recovery. So for example, when a user, as I said, in the initial stages of delinquency, like a 30-day, they might be having a temporary hardship. They could still be employed. They are responsive and have the intention to pay off the loan. So the strategy is not to trouble them more, but to have a low touch automation and give them a chance for using the self-service portal and automated reminders so they are motivated to fix it by themselves. And mid-risk is where you are going into the 60 or 90-day past delinquency stage where the individual needs help and it can be saved if you're having a strategy. So here, not just waiting for an account engagement, instead watch for the signals and decide this is going to happen. And you call them and ask them proactive plans with the support from live agent, structured payment plan, regular follow-up. These things are worth the investment. That way you can recover the loan amount from this individual. The low recovery are the tough accounts. In this scenario, you might need a strategy for intense recovery. Sometimes legal letters might be needed. A potential agency could need to be involved to intervene. Sometimes the efforts need to be escalated. Don't over-invest in this stage because your chances for recovering has gone extremely low. And that's where the secured asset happen. Whatever the collateral used for the loan would be like repossessed during this scenario to pay off the loan amount. Sometimes in the event when this is not happening, a charge off would happen where the loan officer decides this individual is not going to pay off the loans. So the key question here is, how do you know which category an account falls into at the start? That's where recovery scoring comes in. You need to evaluate employment, payment history, contact response, collateral status, and geography. Better segmentation improves recovery rate by 10 to 15% without increasing the cost. On 50 million in annual charge off, that's 5 million. We have explored the core foundations of subprime lending and talked about its challenges. Now let me show you how dotData helps tackle them. dotData helps to find the unknown unknowns. dotData powers your analytic initiatives capability, including multi-table joins and automated feature engineering. Such that thousands of features are explored automatically, something that would have taken weeks. It also explores magic threshold from the generator features, so signals like FICO score less than 620 or debt to income ratio above 42.5% are automatically discovered. This dynamic power of generating insights through driver tracking helps you understand how interaction influence your overall outcome. The unknown piece, that's what we help you find. Let me show you a real example. We have anonymized it, but this is an actual client. The customer here has an 8% first payment default rate overall. Not terrible for subprime, but not great either. And they couldn't figure out what was driving it. They looked at first payment default by FICO bands, by geography, by loan size, by dealer challenge, all the obvious cuts. Nothing jumped out as the obvious culprit. We connected dotData to 5 key data sources, including application data, bureau data, bank transaction data, employee verification, and dealer information. When we had all of this, the tool automatically explored over 2,800 plus features from these sources. Combination and transformation that would have taken a data science team weeks or months to create manually is automatically explored. Then it identified the top 12 predictive drivers for this first payment default. Here is what we found, and this is the kind of insight that could make a difference. Applicants with stated income over 4,200, bank deposits below 2,800, and who applied during evening hours, specifically between 8 p.m. and 2 a.m., had 23% first payment default. It means their income levels are low and their bank deposits are low, and they apply during the evening hours. Maybe they have a financial crunch, and that could be a reason why they applied for the loan. Many of this might not raise a red flag, but as you combine all of them together, it becomes a red flag. This combination of income discrepancy plus the late night application created a high risk segment for them. The segment alone represented about 6% of their whole application volume, but was generating nearly 18% of their first payment default. Now, here is the important part. Could a real sharp analyst have found this pattern manually? Maybe, if they specifically thought to look at the interaction between stated income, bank deposit, and time of pay. But they probably wouldn't have found the optimal threshold 4,200 stated, 2,800 deposit, and applying between 8 p.m. to 2 a.m. So they could have found this by spending hours and hours of it or by talking to domain expert. But within this tool, it's explored automatically in few hours. The result, by implementing score cutoff based on the patterns, the lender caught about 40% of first payment default while only declining 5% of the applicant. That's a huge improvement in trade-off between volume and risk. And this pattern has been sitting in the data the whole time. They just didn't have a way to find it. And that's where the tool could help. In whatever part of the life cycle you are for a lending space, origination, servicing, or collection, most of the customers have found value in each of them. And that's where dotData differs on the traditional BI. When you talk about traditional BI, analysts or data scientists spend a lot of time writing manual SQL code, performing feature engineering, and this could take typically between weeks to months. Whereas in dotData, you just need to identify the tables that are needed. Once you connect the tool will automatically explore the thousands of features and the signals hidden within this feature that has an impact tied to your use case. And this happens within hours versus weeks. The discovery piece, when you're doing it manually, would be like taking lots and lots of iteration. And this iteration could also be time consuming and it needs validation from a domain expert. Whereas in dotData, all of this iteration happens instantaneously. So you would be able to get the results within hours or minutes of waiting for months. And the elements like magic threshold, if we have to do it manually, it's more trial and error, but here it's more statistical. The key insights from traditional BI is talking about what happened, but dotData helps you to find what's driving your KPI, like what we found in the previous example. Is this a tool trying to replace data scientists? Absolutely not. When we are working on this kind of use case like lending or financial transaction, there is a huge need of judgment involved in understanding what's needed and what's not needed, framing a use case, and so on. This tool helps the data scientists and analysts accelerate the use case. The overall development time could reduce a lot, and the insights delivery part is also much faster. So they can spend most of the time on critical decision making. There might be one question on your mind. Let me address it. Because in lending, you are just not talking about black box algorithm. There are regulatory requirements that need to be met. There are fair laws that prevent discrimination, laws about contacting an individual, and so on. And what dotData does is it tries to eliminate the black box so the user have more control. The business driver that dotData generates are human interpretable. They are not mysterious neural network weights. They are things like bank deposits below 2,800 or just made partial payment for the last 2 months. You have the ability to audit, you have the ability to check your data set to see is it true. You have the ability to validate these claims so you can make a decision. This is critical for passing regulatory reviews. Regulators don't need sophisticated model. What they need is a way to evaluate what is being said is true or not. Data is designed to be explainable from the ground up. Every prediction comes with an explanation of which factor contributed and how much. You can document your methodology, demonstrate fairness testing, and show ongoing maintenance. Beyond scores, there is too much emphasis given on FICO scores and other key areas in the loan lending space. But when it comes to subprime lending, the margins are razor thin. So we have to think beyond the typical scores. We get to see the different functional areas like origination, servicing, and collection. Each need unique approach. You can't use a one size fit all model and hope things will all be working across different pieces of it. Finding unknowns. Deep analytics reveals hidden patterns that manual analysis misses. Not because your analysts aren't smart, but because there are too many possible combinations to check manually. A statistical AI discovers what manual analysts can't see at scale. And the overall advantage is also speed. What could have taken months or weeks of effort, data would help you to discover within few hours. And that's the biggest advantage, along with finding the magic thresholds, driver stacking, and explainable AI. So if this resonates with you and you want to explore further, here are some concrete next steps. You can schedule a demo with us. We can run data on a sample of your data and show what pattern exists. We will show you real insights from your portfolio. And you'll also give you access to our documentation so you can see how you can formulate the use case on your own. We have detailed documentation on subprime lending analytics that go much deeper than what we covered today. We can walk you through the full platform and show you how it works end to end. If you have a need to discuss a pilot project, feel free to contact us. We are happy to help. Appreciate you taking time to watch this video. Thanks. I look forward to connecting with you.